Hello everyone, I'm Siddharthan. There is a lot of buzz going around in the tech and AI community about a Chinese startup called as DeepSeek, and this is because DeepSeek has launched their open source large language model, and the important milestone here is they were able to achieve the performance similar to the OpenAI models by using very little amount of resources. So they were able to do that with little number of GPUs and somewhat like minimal cost compared to what OpenAI has been like using to train their models. So this is what they're claiming, but we still need to understand this better, try to understand like what's the performance of these, and there are a lot of things still we need to figure out, but it's interesting to see the advancements that are happening, and especially they have completely open sourced this, so the big players, Google, OpenAI, and other people would definitely kind of try to understand this and make their systems better as well. So there's definitely going to be so much things coming up. So I just thought that we'll try to explore this DeepSeek model, try to see like what we can build out of this. So just for starters, let's see how we can access this locally with Ollama. Maybe ask a simple question and try to compare it with other models that we have in Ollama. I'm also planning to use the larger versions of this DeepSeek in some GPU instance and kind of work with that. So that would also be a good thing. So in this particular video, let's take this agenda where we try to access this DeepSeek model using Ollama. And in the later videos, let's build some chatbot and other applications that we can do. Okay, so let's get started. So for this, we'll be using a LangChain for accessing the Ollama model, or even you can use the Ollama library. But for simplicity's sake, and also to use the chat Ollama thing, I'm using this LangChain community, LangChain and LangChain Ollama. So these are the versions that I'm using. I'll also share this notebook. You can run this if you want. So I've already installed this library, so I'm going to comment this out and I'm going to run this. If not, you can run these things if you don't have this libraries installed. If you're facing any issues with the versions, you can go with this versions, so that should fix that. And the prerequisite is that you should already have Ollama installed on your machine. So I've already made a video on that, you can refer to that. So in Windows, usually like Ollama kind of runs in the background. So if it's running, what you can do is open your PowerShell. So maybe I'll go to my desktop and open this terminal. So we have Windows PowerShell here, right? So the first thing that we need to do is pull the DeepSeek model. So what I'll do is I'll say Ollama list. So this is going to list all the models that I've already pulled. So here, as you can see, I have a DeepSeek R1 model. So this is their reasoning model. So 1.5 billion, which is a smaller distilled model from the bigger R1 models, and the size is like 1.1 GB, which is like pretty smaller size, and but it's really good. And then we have Gemma 2 billion, which is again 1.7 GB, and so on. So the first thing you need to do is make sure that you have installed Ollama and Ollama is running, so it should run automatically, so you shouldn't face any issues there. And after that, you can come to this DeepSeek Ollama. So you can just search DeepSeek Ollama and you will see this DeepSeek R1, DeepSeek Coder V2, and so on. So this V3 is the one that they have kind of given. We'll search and show this to you. And also the models details are also given in the DeepSeek page. So we have this DeepSeek R1 is now live on open source. So this is the reasoning model which you can compare it to OpenAI's O1 model, which is their reasoning model. And then we have DeepSeek V3, which is like kind of working as good as the GPT-4o models, and we have like all the scores and so on. You can see the model architecture and other stuff. So for DeepSeek R1, right? So they have also kind of distilled this and made that available in the smaller versions. So we have a 1.5 billion version, 7 billion version, and so on. So what you can do is you can just go through these models and other stuff, but we are going to use it locally. So that's one main requirement. So for that, you can just search DeepSeek Ollama. So you will see this DeepSeek R1. So distilled models. So these are like kind of the smaller versions of the model to reduce their size, but they do preserve like some amount of performance that we see in the major model. So we have this DeepSeek R1, right? So this is their bigger reasoning model, and that's like kind of distilled to the smaller version. So we have 1.5, 7 billion, 8 billion, and so on. So if you have a smaller GPU, you can use 1.5 billion, which is again about 1.5 gigabytes. If you have a larger RAM, you can like use the larger versions of the model as per your choice. And then we have DeepSeek V3, which is again another state of the model that they are providing. So that's also something that we can try, but it is a pretty larger model, so you would need a very big GPU to access it. Maybe I'll show this to you. So if you click this, you can see it is like 404 GB. So yeah, again, it is like a quantized version. So even the original version should be like much bigger than this. But yeah, let's use this DeepSeek R1, which is the reasoning model, and then we have this 1.5 billion, 7 billion, 8 billion version, and so on. So we can use this DeepSeek R1. So Ollama Run DeepSeek R1. This is the default version, the 7 billion version, but let's use this 1.5 billion version. So what you need to do is this is running this DeepSeek model, but first you need to pull that. So instead of this Ollama Run, say Ollama pull DeepSeek R1 1.5 billion. So maybe I'll copy this, paste it over here. So instead of run, I'm going to say pull. So I've already pulled this, so it should, I mean, we don't need that, as you can see. So I've already pulled that, so it's kind of giving that. So once you have pulled, you can again check this Volama list to make sure that it's kind of present over here. So if you want, you can also pull the Gamma 2 billion model, and you can also do some comparisons in that. So now I'll open my Jupyter notebook. So the first thing that I'm going to do is import from LangChain. We'll see if I need to increase this. Okay, I've increased the zoom of this. So I'll say that from langchain underscore Ollama. So this is the Ollama integrated version of langchain. So we that's installed using this Ollama, sorry, langchain Ollama. So I'll say from langchain Ollama import chat Ollama. So let's run this. So this is going to import this particular module, and then I'm going to say loading the DeepSeek R1. So you can see there's R1 smaller R, which is the distilled model, and say LLM is equal to chat Ollama, and then you can pass the model parameters. So first is the model variable where you need to give the name of the model. So name of the model is what we are seeing in this Ollama list. So you can copy this and paste it over here in this model within quotes, and then you can use other parameter as well, but for simplicity I'll just go with the temperature 0. So that's going to give you consistent result every time you ask a specific question. So this is the model. Let's run this. Now let's ask a question here. So I'll create a variable called as response where the LLM's response will be stored. So I'll say llm dot invoke. So this will call this LLM, but also we have kind of kept that in chat Ollama, so it would work as if a chat model. So I asked ChatGPT to, give me some questions that I can use to test a reasoning large language model, and it came up with a particular question. Maybe I'll use that one itself. So here I'll say if all cats are mammals and some mammals are black, can we conclude that some cats are black? Why or why not? So this is a question where the model needs to reason this. Let me put this way. Okay. So if all cats are mammals and some mammals are black, can we conclude that some cats are black? So why or why not? So this is the question that we are asking this, and we are going to kind of invoke our DeepSeek model, and let it answer this question. So here I'll run this. So we are using this llm.invoke in order to get a response, and based on this GPU, the amount of response time differs for you as well. So here now I can print this response. So we have this clumsy little text over here. So instead you can just print this response, print response dot content. Even that would look the same. So the thing is, this is in markdown format. So what we can do is uh, print this. Instead of printing this using this print statement, we can use markdown in IPython display. So that's going to format all these bold letters, new lines, and so on. So let's do that. So for that, I'll say from IPython dot display import markdown and display. So these are the two things that we are going to use. Again, you don't have to do this. So instead, you can also create a text cell in Jupyter and paste it here, so that can understand the markdown format as well. And then I'll say here we are going to print the string in markdown. So I'll say display Within that, pass this markdown function that we have imported, and within that we have to pass this response.content, which is a string data. And now the text will be formatted, and it would be like easy to read and all that. So here we have the question saying that first, I need to understand the given premises. The first premise states that all cats are mammals. This means every cat belongs to the category of mammals. The second premise tells me that some mammals are black. This indicates that there is an overlap between the set of mammals and set of black things. So basically, we have mentioned or given two statements that all cats are mammals and some mammals are black. So based on this, tell me we can say that some cats are black. So this is the question that a reasoning question that we have asked, and here you can see the process in which the model is thinking, right? So and then it is also kind of trying to build that solution up. So it says that let's analyze the given statement step by step. So premise one is all cats are mammals. So this means every cat belongs to the category of mammals, and it is looking at the second premises and trying to conclude that. So since all cats are mammals and some mammals are black, it logically follows that those black mammals must also be cats. Again, it's based on the statements that we have given. This can be a bit tricky as well. So finally it says that yes, we can conclude that some cats are black. So this is the response that we are getting. So this is the response from a reasoning model. But if you kind of use this on a OpenAI O1 model, so it would kind of work in a similar way. But if you ask this to a GPT-4 or a different model, that would work in a different way, as they are not like hardcore reasoning models. So this is how we can access this DeepSeek R1 model 1.5 billion version. Again, if you have a larger GPU, I would suggest you to go with a larger model that could, your GPU that could accommodate it. And the other thing maybe that we could do is ask the same question, but in this case, let's use Gemma 1.5 billion or the Gemma 2 billion version. So I'll paste it over here. So here we are going to compare it. So I'll create this as a markdown, compare it with Gemma. Okay. So instead of DeepSeek R1, I'm going to copy this Gemma 2 billion thing and paste it over here. So now we are loading Gemma 2 billion instead of the DeepSeek model. And again, call this same question. You can use the same variable, so that should be okay. Same question and all that. And finally, I'll maybe use the same markdown display over here. So the premise of the question is logically incorrect. The statement is not valid. The fact that cats are mammals does not automatically imply that all cats are black. So this is not what we are trying to conclude, but you can also see the difference in how the two different models are working, right? So that's other thing. But the main idea that we want to understand is like how we can access this. But as you can see, there is a clear distinction between how a reasoning model would work and our another large language model would work. Again, if you are using a Kema larger version, you would also get a different response. But the thing about this reasoning model is they are able to understand this question better. They are able to reason what's given to them in a better way. So this is how we can access this. So in the next steps, right, in the upcoming videos, let's try to work with larger models. And DeepSeek also given like other models as well. So if you just search in Ollama itself, right? So we have DeepSeek R1, which is the first generation of reasoning models with comparable performance to OpenAI O1, which is OpenAI's reasoning model, and it includes 6 dense model distilled from DeepSeek R1. So these are those models that we have, and then we have DeepSeek Coder V2, the code based models and so on, V3, and all those aspects are there. We also have a DeepSeek LLM, advanced large language model crafted with 2 trillion bilingual tokens. So let's try to explore different models. So I'll try to spin up some GPU instance and I'll try to demonstrate this to you. But this is actually fascinating to understand like how much they have, they are able to achieve this. Again, the details are not yet complete over here. It's still that buzz is going around, so we still need to wait a bit in order to understand how good it really is. But I hope that it's kind of in a good way, and based on this architecture and design, the other players should also be able to take leverage of that, as this is like completely open source and free to use commercially as well. So I hope you are excited as me as well. So I'll see you in the other videos. So that is all from my side. Thank you.